For those of you that requested this video on mole concept, I'm going to go through those 4 questions that are on the worksheet. So let's begin with question 1. What amount of oxygen, O2, in moles is contained in 1.8 times 10 to the 22 molecules? So what you're going to do first, and that's what I encourage you to do, is just write an equivalent statement. We know that 1 mole contains 6.02 times 10 to the 23 molecules. Well, really, 6.02 times 10 to the 23 of anything, but here we're dealing with molecules. So the question wants us to find out what number of moles, let's call this X, will contain 1.8 times 10 to the 22 molecules. That's a simple, straightforward question. I just need to solve for X, and therefore X will become 1.8 times 10 to the 22 divided by 6.2 times 10 to the 23. Get my calculator out. And that becomes 0.0299 molecules, or rounded off to 3 decimal places, that becomes 0.030 molecules. And so that answer seems to be B. Okay. We're going to move on to number 2, where the question is asking us which compound has the empirical formula with the greatest mass. So clearly here we need to find the empirical formula first for each of these compounds, which, if you recall, the empirical formula is just simply the simplest whole number ratio. So here in A, the simplest ratio for the C2H6 molecules between the carbon and the hydrogen, it's a 1 to 3 mole ratio. It's a 1 to 3 ratio. For B, that would become 2 to 5. For C, that would become 1 to 2. And for D, let me make it clear that that's a 1. And for D, that would become C1H1. So we have found the simplest whole number ratio. And the one with the greatest mass would be the one that has the greater number of atoms, which in this case happens to be compound B, which has 2 carbons, 5 hydrogens. That's a total of 7 atoms. Here, because all of them have carbon and hydrogen, I'm simply just going to analyze it in that way. If there were different atoms, then you could also go ahead and just work out the mass for each of those empirical formulas. So in this case, that happens to be B as the answer. Then we will look at question 3. Now, I know some of you struggle a lot with balancing the chemical equations, but it's something that is going to get easier and easier the more you practice. So I'm going to rewrite the equation down here so you can actually see what I'm doing. So we have C2H2 plus O2 to give you CO2 and water. And the question simply is stating, when the equation above is balanced, what is the coefficient for the oxygen? It's a good idea to make sure you highlight your keywords so that you focus your mind on what the question is asking and you won't become confused or mistaken. So, I normally start out with the atom that is in only one compound on either side of the equation. There are some atoms that are in 2 different compounds on the same side of the equation. When such a problem arises, as in this case with the oxygen, which is in two different compounds on the same side of the equation, I would suggest you leave that atom until the last. I promise you, your lives will be much easier. So I'm going to start with carbon. There are two carbons on the left-hand side of the equation, but only one on this side. So in order to balance it, I'm just going to put a coefficient of 2 in front of the CO2. So now my carbons are balanced on both sides of the atom of the equation. I move on to hydrogen next, where I have 2 hydrogen on the left-hand side, 2 here, so I know that my hydrogens are balanced, and that's good news. Now I've come to the oxygen, which I've deliberately left until the last, and that's because, as I've stated before, the oxygen is in 2 different compounds, so it will present a little bit of an issue when if you started balancing the equation with oxygen initially. So we're going to say there are 2 oxygen atoms on this side. There's 2 times 2, that's 4, and 1, 5. So I have 5 oxygen on the left-hand side, 2 on the right-hand side. In order to get them equal, I'm simply just going to put a 5 over 2, or 2.5 oxygen, O2, on this side as a coefficient to get them balanced. Because 5 over 2 times 2, that gives you 5. So now it's balanced. But if you look at the equation, you notice that there is no fraction. So sometimes simply what happens is, instead of giving the coefficients as a fraction, so here that would be 1 to 5 over 2 to 2 to 1, we use the simplest whole number ratio. And we will achieve that by multiplying everything by 2 to get rid of this fraction here. And that becomes a 2 to 5 to 4 to 2. And we're just going to put that in. So that's 2 C2H2, 5 O2, 4, and 2. Now, if you have an alternate method of balancing the equation, feel free to use it as long as the concept is sound. And so back to the question, what is the coefficient for oxygen? That would become a 5. Now, this last question, some of you were complaining because it just looked so difficult, but I promise you, just read through the question carefully and underline your keywords, and it should help you to become focused. So there's 3 dm cube of sulfur dioxide, which is SO2. With 2 dm cube, it reacts with 2 dm cube of oxygen, according to the equation below. And you have the equation. What volume? So the question is asking you for volume in dm cube for the sulfur trioxide is formed. Now, they gave you a little statement in bracket. Please do not ignore it. It's very important. It says, assume that the reaction goes to completion. That means you will need to identify the limiting reactant. And all gases are measured at the same temperature and pressure. This is very important. Immediately, you should start to think about Avogadro's law. And Avogadro's law, the important statement is that once the gases are at the same temperature and pressure conditions, it means that their mole ratios are same as the volume ratios. So when I have my SO2, 2 moles of it reacting with 1 mole of oxygen to give me 2 moles of sulfur trioxide. So if you look here, my mole ratios of 2 to 1 to 2 should really, if the reaction goes to completion, should be the same as the volume ratio. So I'm going to use that idea to determine what the limiting reactant is. And I'll simply do it like this. I'll say to myself, if I have 3 dm cube of SO2, based on the mole ratio, I need half that amount of oxygen to react. So 3 dm cubed really should take half of that, which is 1.5 dm cube of oxygen. I actually have more oxygen than I need. So in that case, it means my oxygen is in excess and my SO2 is a limiting reactant. If you had started with the oxygen, you would have still arrived at the same answer. So for example, if I said, how will I get 2 dm cube of oxygen to completely react? 2 dm cubed of oxygen to completely react, I need twice as much SO2. So I need 2 times 2, 4 dm cube of SO2. And that means I do not have enough SO2 to get all the O2 to react completely. So it means that my SO2 is a limiting reactant. Now, remember, the limiting reactant is what determines what goes to completion. So the ratio of SO2 to SO3 is 2 to 2, or simply 1 to 1. That means the same volume of SO2 that I have will be the same amount of SO3 that I produce. So I started out with 3 dm cube of SO2. That means I will also produce 3 dm cube of SO3. And that is the answer. Good luck on your worksheet.